Okay, now in the last session, we were trying to see how is that basically we can create a container, and then how do you start a container, how do you stop a container, and then how do you give a name to a container, and practically how will you go inside the container, what happens, and when you come out of the container, what happens, and in case if you want to run a container in a standard demonized mode, how is that you can run. So those are the things that we were seeing. In that, just to quickly recap, if you want to create a container, you will say docker run and give some options in which you will say -name and the name of the container, and -it represents that you have to interactively attach our terminal to the container so that we can go into the container as soon as we create in it, and whatever commands that you want to run, we will be running. And in that, we will be giving the option of the name of the image which it has to use to create the container. And then we will be giving the entry point or the first command that we want to run inside the container. Okay, so in that, every time when you say exit, the container will get stopped. So that is how, if you want to start the container again, you can say docker start and the container name or the container ID, and to attach it, you will say docker attach and the name of the container or the container ID. Okay, so this is what we were seeing in the last session. To continue on top of that, now, just like how we saw the start of a container, if you want to stop a container, you can say docker stop and the container name or a container ID, and it will be stopped. Okay, so let's say I have this particular container running. So if I want to stop it, I can say docker stop and the container ID or the name of the container. So now after you enter it, it will be stopped. So if you want to look at the container status, the same container, you can see now it is in the exited mode because we have stopped it. Okay, so that is how you can choose which container that you want to run, and you can start a container, stop, or you can attach a container whenever you want. So that way, now how do you look at what are the containers that we have created in our machine and which of them are running? For that, we will use an option called docker ps, and that will give you a list of containers that is available in our machine. So if you say docker ps, and it will show only the list of container which are currently running. Okay, so in that case here, let's take this for example. If I say docker ps, you can see it is not displaying anything, which means that there is no containers currently running, because by default docker ps will give you a list of only that container which is running. So quickly, let me start a container with this ID that I've created. Now if you do docker ps, you can see there is one container which is running. So that is how the docker ps will show only that processes or the containers which is currently running in our Docker engine. Okay, if you want to see all the list of available containers in our machine that we have created, then you can say ps-a. So it will show you all the containers that is available in our machine, whether it could be running or it is stopped mode. So it will show you everything. Okay, so that's the difference between ps and ps-a. So if you want to see everything, then say -a. If not, docker ps will show you only the list of current containers which are running in the Docker engine. Okay, this is how we will be seeing the status of a container. Now, what if you want to delete the container? Then you will say docker rm and the container name. Okay, so if you say docker rm and the container name, it will not only stop it but pretty much delete the entire container at all. You will not be able to access it anymore. Okay, so let's say if I want to delete these container, then if I simply say docker rm and the container ID, it will delete. So I can delete everything one by one. So if I'm no more interested in working on this, or if I don't need this container anymore, you can simply go ahead and do a docker rm. So all the containers will get deleted. Okay. Now, that is how we delete a container whenever we don't need it further. Okay. Now, when you're working on a container, it's not always that as a developer or as a QA, you might need it as a replacement for a machine. So for that, you will be saying docker run and you will be trying to go inside it and run. But from our DevOps concept of automation, we might be using a machine where I don't have to log in or go into this always in terms of container. I just want to have some application inside it and it should be always running. So that way, there will be many containers that we will be creating in a demonized mode or in a background mode, so that we don't interact with it. We just say what is it inside it and it will automatically be running inside it. So now if you want to see what exactly are the processes running inside a container, then you will say docker top and the container name or the ID, so that whatever is the processes inside the container which is running, you will be able to see that. Okay. Now let's say I want to see the list of processes running inside this container. So then we'll say docker top and the container ID. So now inside this particular container, now there are two processes running, wherein if you recall, this was the daemon container that we created, where I showed you example of running a small shell script to print every 1 second a message called hello world. So that is running inside, and because of this you can see that these are the processes and what is the process ID that is using inside it. So that is how, without going inside the container, you can exactly know what and all is running, so that if we need, we can inspect what is happening or what processes is running inside the container using the top. So docker top means it will give you the list of all the processes which is running inside the container as if it is a separate machine. Okay. Now, every container that you create, it will be acting as a separate virtual machine. So it also has almost all the properties like how you create a new machine. So in that way, if you want to know all the properties that is assigned or created along with the container, for that we will use a command called docker inspect. So now for the same container ID, if I say docker and inspect and the container ID, it will be giving you a huge list of output in a JSON format. JSON format means it will be available in the flower bracket format. Okay, so you can see the output. Okay, it's a wrong one. Docker ps. So you can see now it is actually giving an output in a JSON format, where in a JSON format you will be having everything within a flower bracket, where you will be having the values in a key and a value pair. Okay, so like this, the complete properties about that container for the container ID that we give will be available in this, so that we can see what exactly is the system properties that is used by this particular container. So now again, this is going to be giving you the complete data from which you can grep. For example, if I want to get only the details of the IP address, then if I simply say grep IP, it will be giving me all the matching string from this output, right? So this way I can get, but to be more effective, we can use the inspect and use a format in which particularly it will be giving you only the data that you need. Suppose if I want to search only for a value of the IP address from this particular container, then there is one key pair value called as network settings, and under that you have IP address. Okay, so that is how you can exactly get this value from the inspect rather than getting all the value. So now here, if I say the same container ID, rather than like a regular grep, you can see it is going to give you the exact output of only that key and a value corresponding to it. Okay, so this is the name of the key, and corresponding to it, whatever value it is trying to show. So that is how you can use the format option along with inspect and take only the particular output. Suppose if I want to see what is the status of the current particular container, then here I can give the key name as settings and in the state running. So if it means true, it indicates that currently the container is running. So that is how, rather than getting the complete output, you can try to format and choose a specific output out of this JSON format, so that only the value corresponding to the key it will be trying to display. Okay, so that is how you can get any property out of the container by using Docker inspect. Getting it? Okay, now to continue, as I said, when we are going to use container, there will be many scenarios where you have already created a container and you might be running it in the background. Because if I want to connect to a container, I can attach the terminal, and inside that we can say whatever command you want to run and it will be run inside it, correct? But what if, let's say there is a container which is already running and you don't want to go inside it and run something, because what will happen now, as soon as you go inside the container, that is when you're attaching your terminal, after running the command, if you say exit, the container will be stopped. So that is one, if you want to run something inside a container without attaching to it, then you will be using a option called docker exec. Okay, so if you say docker exec, and if you gave the name of the container ID without going inside it, what the docker will do is it will take this command, whatever you have given for the exec, inside that particular container it will be running it. Okay, so that is how, without attaching to a particular container, what you can do is you can try to run the command inside the container. Okay, now let me show you that. So let's start this particular container. There is one container with this ID, correct? So what we will do is, first let's start, and if I attach, we will be inside it. Okay, just to verify, here under the temp folder I am creating a file where I will say container dot the name or the ID of the container. Okay, so this is available under the temp folder of this container. Okay, now here what we will do is, if I do an exit, I'm going to come out of it. Right now let's start it once again, and because of that, if you say docker ps, you can see this container is currently running. So now without going inside it, if you want to run some command, we can run it using docker exec, and what is the command you want to run, and then the container ID that you want to give. Okay, so that way now first what is the container ID you will give and what is the command that you want to run. For example, if I say touch temp test file. Okay, so now if you see, this command is run inside this particular container. Okay, and even before that, now if I say host name, it is giving the name of the machine on which we are running. The same thing if I run this, you can see it is returning the container ID of this, because this command is executed inside this container without going inside the container. Same way, if I want to attach and go back to the container, you can pretty much go, and in the temp folder you will be getting it, as well as you can see that it has created a new file, because earlier when we created there was only one file, right? Whereas now when we went inside and we were able to create the file or run this command without going inside it. Okay, so that is how, if you have a container and you do not want to attach the container and then run something, then directly using docker exec we will be able to run the commands without going inside it. Getting it? What do you mean by exec? Hello? Yes, the container should be running, right? If the container is not running, you cannot access it. So basically, if a machine, just think practically in the other way. If you want to put some file or do something into a machine, the machine should be running. So that is how, even in this case, a container is acting like a virtual machine, where if you want to run something, you need to make sure it is running. Only then you will be able to get inside it and run, but without attaching to the terminal. That is the difference here. Getting it? So the container should be running. If not, we cannot run the exec, because the container itself will not be there if it is not running. Got it? No, you cannot do it. That's the reason we will be doing a daemon run background, because when you are starting a container and if you want to come out of it, then the problem is it will exit it, wherein now you can use an exe command. Suppose you want to run anything, so let's say you want to run something inside the container. Now you put it into the script or a command, then come out of it. As soon as you come out, what will happen? It will do a exit, right? So then you start the container. After starting the container, you can use the exec and you can say what is the command that you want to run inside the container. So the Docker will automatically run the command inside the container without going inside it. So that is how you can make sure that it is running it. See, exe is nothing to do with what is already running. See, if it in a machine, let's take a Linux machine. If a Linux machine is running something, if you try to connect and run some other command, will it wait? No. Practically, based on number of threads that it is going to have, it will be running everything. The same thing here. Whatever you are going to run inside the container will be running. Additionally, you are going to use Docker exe to go inside the container and run without attaching the terminal. That is the difference. Okay, so you have to think that a container is nothing but a actual virtual machine. So anything that you can do on the host can also be done on it. Okay, so that is when exe means exec is used to run something in a container without attaching the terminal inside the container. Directly if you want to run, then it will be running it using exec. Okay. Okay. Now, so there will be some scenario where you are going to run a container, and once again you might be running a container in the background or in the daemonized mode, and you want to see what and all are the resource usage that is happening inside the container. So that case, what you can do is you can try to run a command called docker stats. Stats represents statistics. Okay, so what is the resources that is being used within this container as a machine, and then what is its output? It will show you a live output using this docker status and the current container ID. So now let's take this. So currently there is one container running. So here, if I say docker stats and the container ID, you can see it is actually going to show you a live screen on what is the usage inside that particular container. Okay, now let it be running. Quickly, I'll show you in another screen. We will try to run some commands inside it and see how the load or the resource utilization goes up. Okay. So this is the container. Okay, inside the container. Okay, maybe I'll put it here. That will be better. Okay. Now, from this, what we will do is I'll try to install a Apache inside it. Okay, so that is what I'm going to do. What I'm going to do, I'm going to use Apache. Okay, now what I'm going to do on this container, docker exec and the container ID. So what I'm doing is I'm trying to install Apache inside this container, okay, wherein this container is based on a Ubuntu base image. So I'm going to use a package name called as apt-get, which will try to install a package name called Apache. Okay, so if you look, okay, it's actually not able to. Let's do update. Okay, do you see here the utilization is going high? So whatever that is happening inside the container, you can have a live monitoring on what is the resource utilization that is happening on that particular container, because this container is acting like a separate virtual machine. So it will also have the memory, the input output, and then it will also have the CPU specific to it, right? But everything is being shared from our host machine. But as a container, what is the resource utilization that you want? You can try to check that using the docker stats, wherein it will be showing you the live output of the statistics that is being used. So whenever you have done, you can do a control C and it will come out. If not, if you say docker status, it will show you a live output on the usage of the resources on that machine. Getting it? What do you mean by stats? Did you get it? Okay, now there's something called as events. So whatever that we do in the Docker, right, it's actually going to track it as an event. So what exactly is an event? Event is nothing but some kind of activity that happened at a particular point of time. Okay, so in the same way, now in Docker, everything is going to be an event, like creating a container, stopping a container, starting a container, running something inside it. Okay, so everything is going to be a event name. Now if you want to do a management of the containers, like let's say I'm using a machine and on that machine many users are using containers. So if I want to know how many containers are created or what exactly is happening on the Docker engine, I can use a option called as Docker events, and we can try to see the list of outputs based on that event. By default, if you say Docker events, it will try to give you all the live output. Okay, in the same way, if you say Docker events, whatever the live event is going to happen, it is going to show us here. So just watch the screen. If I say Docker run, for example, -it ubuntu and bin bash, so you can see we have just run one command, but internally for that, it has created so many events, and based on that, we are working. Where first we created a container and then we attached ourselves to it, and specifically there was a network IP address associated, and then we actually started working on the container inside it by giving the shell. So that is what exactly it has done. So like this, now if you want to see all the list of events and you want to track it, then you can say Docker events, wherein by default Docker events will show all of them whatever is happening. Now let's see, if I say exit, for that also it is first calling a event called die, and after that it is trying to disconnect the network and then come out of it. So like this, for each command or step whatever you're going to do, there will be equally some kind of event that the Docker is going to capture. Okay, now if you're not interested on everything, then you can use a specific option called filter along with event, and you can say what exactly is the type of event which you're interested to do. Now let's say I want to check for the event called attach and not anything else. So then in this, if I say Docker events, filter event equal to attach, then only if you are running a attach event, then it will be displaying. If not, no matter whatever that you are trying to run, it will not show you that. Okay, so let's try that. So now if I say Docker run, in this, there is one attach that we saw, right? So only that is being showed. Suppose if I exit, still it will not be showing. So only if you run, let's say Docker start and this, again it is not going to show. But if I run the command called docker attach, only then it will be showing here. Okay, like this you can choose what particular event that you are interested to see, and based on that only that event's output will be shown here, wherein now we can actually combine more than one events. Like suppose if I want to see all the attach events and the die events, then I can combine both of them, wherein as many filters as we want we can add into it. Okay, and again in simple, suppose let's say for the past 1 hour whatever is the events that I wanted to see, then if you just say events hyphen since and 1 hour, it will try to show from the last 1 hour whatever events that you have run, everything will be available. Okay, okay, so you can see now it is going to show you the live output until the last 1 hour, what and all it has run, it will show you, and along with it, it is going to show you the live output, so that if you run anything, it will take that and it will also show it. Okay, so this is how, for any kind of event management that you have to do for the Docker that is on the container, then you can try to use the events, where you can try to see the exact output, and if you want to track it and store someplace, you can use that for tracking. Okay, so events means it is going to give you all the specific event types that is going to happen. All right, getting it? Okay, now comes an important topic. So far, what is that I said? A container is nothing but a virtual machine, where instead of creating a new machine, you can simply create a container, go inside it, and work as if it is a new machine. Correct? Now, let's do the same thing, and let's say that I want to install some particular web application, and for that I'll be using a container, and inside that I'll be working. For example, to install Jenkins, now let's say I need a machine. Now, instead of installing Jenkins separately on a new machine, I can create a container, and inside the container I can run a Jenkins or any kind of web application. Okay, so how is that you're going to access? If you're saying we have to access it, now basically when you take any machine, okay, now let's say that we have a machine here. Okay, this is a machine. Now let's assume that, and so inside this machine, suppose if you try to install Jenkins, okay, let's say this is Jenkins that we have installed it. Now, if you want to access this Jenkins, what is that we will do? Now, to connect this, basically we will say what? We will say the HTTP and the name of the machine :8080, so that it will be directly connected to the particular web application running in the port 8080 for this in the Jenkins, right? So that is what even we did in the last class. Remember, so if you have Jenkins installed in some location, if you want to access, if you say HTTP the name of the machine :8080, it was directly accessing it on this machine. But now the scenario what I'm saying is, if you have a particular machine, host machine, and in that you are actually creating a container. Okay, so let's say this is the container, and inside the container I have actually created a Jenkins or installed Jenkins. So now when you try to access it, it will not be able to access, because it is like a machine inside a machine, and inside this machine you have Jenkins available. So for these kind of scenarios where when you have an application inside the container, then we will not be able to access directly from the host machine or from the outside. If you want to connect, you are not going it inside the container, because the only place we will be reaching is the host machine. So what is that we can do so that we can access the web application which is running inside the container? So for that we will be using a concept called as port mapping. Okay, so what do you mean by port mapping? If from outside you want to connect, you will be always connected only to this particular machine, and in that whatever port is available you will be connected to it, right? So now what we can do is, when we have a container in which you have certain applications like web applications running it, and if you want from outside the host machine to access, then we can try to port or to map this particular port number or the application running inside the Jenkins to the host. Okay, so I can do a mapping like this. So if I do a mapping, what exactly it is going to do? It is going to basically create a replica of the same port number, in which the same port number will be available here with a different number that you want. For example, if I want, I can keep it as 8090, just an example. So now what you are doing is you are trying to map the port number available inside the container, that is 8080, to a port number called 8090, which is available on the host machine. So that now if anyone is trying to access this 8090 from the host or outside the host, they will be actually redirected to connect to this particular Jenkins which is running on-site container. Okay, so that is how. Now in order to access this, if I just say HTTP and colon the name of the machine colon 8090, what you're going to do, you're basically trying to connect from here to here, right? But this is not exactly a port which is running on this machine, whereas this is just a map to the actual Jenkins or the port running inside this container. So that is how when you try to access this, this will be going inside the particular container and you will be able to access it. So that is how, if you're running a web application inside a container, you will have to do this concept of exposing the port, where when you say you are exposing this port, you are basically trying to map the port number inside the container to the same port number or some other port number on your host machine, so that from the outside we can connect only to the host where these port numbers will be available, so that we can now try to access it. But internally, due to the mapping of the port number, this 8090 will be redirected to 8080 inside this particular container. Okay, so that is what we call it as exposing. Getting it? What do you mean by exposing a port? Others? Okay, now let's try to run an example and see how it is going to work. Okay, so now let's take our simple application server called Nginx. Okay, now here I am trying to use an image called as Nginx. So what is the purpose of this? Whatever the container that we are going to create, basically it will be containing a pre-installed Nginx application or a Nginx web server. Just like how we have Apache and JBoss, one of the most popular open source web server is called as Nginx. Okay, now what I'm going to do by this command is, by running the docker run, it is going to create a new container based on this particular Nginx image. And in that, if you want to access, you need to do the mapping. So that mapping is what we do it using -p, where if you say -p and the port number of the machine or the host which you have to map to the port number which is available inside the container. Okay, so that is what we are going to do here. So now watch very carefully. So if I say docker run, and for the docker run I'm going to say -p and the port number which I have to expose. Okay, so now -d means I want to run it in a demonized mode, and in this I'm going to say 80:80 so that whatever the container creates, and inside that whatever the Nginx web server is going to run on a port 8080, you map that to the 80 of the machine, so that now if I directly connect to this machine and say 80, it will be redirected to the container, and in the container the Nginx web server will be accessible. Okay, so that is what this means. So as of now, you can see this image is not available. So it is trying to download the image first from the Docker's open source community, and then it is basically created a container and it is currently running. So you can see that there is a container running, correct? But now what is that we did? We created a new container in which we ran a Nginx in which it is created in a port 80, and that we are trying to map to the 80 port of your host machine. So now if I say HTTP the name of the machine and say :80, it will be directly accessing the Nginx web server running inside the container. Okay, so that is what we are trying to do now. Okay, so simply if I go to the web page, and here what's the name of the machine? Okay, I can give this or I can give 80, both are one and the same. Okay, so you can see now we have actually connected to the Nginx web server. Where is it installed? The Nginx is installed inside this container. And how is that I'm able to access? Because while creating the container, we have told that map the 80 port of the Nginx which is going to be run under this container to the 80 port of the host machine, so that from your host machine, or if anything is been trying to connect to your host machine on port 80, it will be redirected to this 80 inside the container. Getting it? You're getting it? What do you mean by exposing a port? Others? Karnakar, Nagesh. Clear? So this is how, when you are trying to create a container, especially for all the automation purpose that we are going to do, we will be running everything in the demonized mode in the background. And in that, if you want to access a application running inside that particular container, you cannot directly access. So basically we have to map the port number to the host machine, and from that we can try to access it. Okay, so that is what we call it as exposing the port. And while exposing, if you just say -p without any port number, then if you have more than one port available inside your container, everything will be mapped to the same number on the host machine. Okay, so all the port, everything will be mapped at one shot, wherein the same ID will be ported to the host machine, so that if you try to connect the host machine with that port, the same one will be contained, or it will be trying to reach it inside the particular container. Okay, is that clear on what do you mean by exposing a port? Okay, Coming to other important thing. Now, since containers are going to be treated as a machines itself, but a virtual machine. Now, if you want to copy between two machines, we can try to copy or share content through something called as NFS, right? Network File System, where from one machine you can share some content into the other machine. Now, what is that we can do inside a container? Because ultimately, even a container is going to act as a machine inside it. So, we should be still able to copy or share the content between two containers, just like how we do it on a machine. So, if you have such a requirement where we want to copy or share content between two containers, then we will be using something called as data volumes or volumes. Since you are going to use volumes to share some data, we also call it as data volumes. But pretty much a data volume is nothing but the mechanism using which you will be trying to share content between two containers. Okay. So what exactly is this mechanism? Now, a volume is actually a special directory within a container or more than one container, using which we will be able to share some content. Okay, so when you say that you want to create a volume on a container, it is actually a directory, but it is not an ordinary directory, a special directory using which we will be able to share the content between the container. So majorly, if you see, volumes or data volumes will be used to share some data between two containers. Okay, how will you do? By creating something called as a volume, which is nothing but a directory. You can use it to share between one or more containers. And let's say that you have two containers, container 1 and container 2. Okay, and from container 1 you are trying to share some data to others. Now let's say that, let's say you have one container, okay, and then you have another container. This is one container and this is other container. So now in this, if you have a special directory which you have created and you are calling it as the volume, and if you want to share from one container to other container, now you don't have to keep this container always running. Okay, so that's the difference. Because now if you are trying to share some data from one container's volume to another, then while sharing, it is not necessary that the container should be running. Even when the container is not running, you can still access the data from that particular volume available inside the container. That is the advantage, because same thing, if you are trying to do it on a machine over the NFS, only if both the machines are available you can copy or access the data, right? But in this, even when the container is not running, you can still access the data which is available inside the volume. That is the advantage of using data volumes inside containers. Okay, and remember, when you do any changes to this particular volume in the container, whatever that you are trying to map it, so from here you might be mapping it and sharing the content inside this. So that way, whatever the changes that you do here will be directly reflected in here, because it is a shared location or a directory that you are using. Okay, so that is how anything that you store here or share will also be available or accessible here. And this particular volume will be available as long as this container is there, but it is not mandatory that it is running. If it is just available on your machine, you can try to access the volume from that container. But if the container itself is not there, then correspondingly the volume inside the container will also be not available. Okay, getting it on what do you mean by volume? Volume is nothing but a directory using which you can share content between one or more containers. Okay, so how is that you're going to create a container? So to create a container, now we will be using an option called as -v and specify a path inside your container, so that if this directory is not available, it will create a new directory, but it will be treated as a special directory to share content between two containers. Okay, so now let's try to see this. So quickly, if I want to go inside this particular container, now let's see whether there is a directory called user data inside it. Okay, so under the user folder, you can see that there is no data folder, or in fact there is no user data folder inside any of the containers what we have created, correct? So now what we will do, we will create a new container, and in that container we will create a directory which is going to act as a volume. Okay, so now we'll say docker run, and I'll give a name here, and the name I'll give it as vol container. Okay, it's just an indication that I'm using it for volume purpose. This is the name, and in this I will say -it, and then you will say the volume paths that you want to create if it is not existing, and then followed by this you will be using the name of the image and what is the first command that you want to run. Okay, so now we are inside this container, and the name of the container is vol count, and in this, now if you go to user folder, you can see there is a data folder created. It is just a normal folder, but it is going to act as a special folder where anything that you store inside it, we can share it and we can access it from another container. So I'll go inside the data, and here I'll create a file. Okay, so I'll say touch, and we'll create a new file called dummy. So what is that we did? We have actually created a new container in which there is a volume that we have created under the directory called as user data, and in this I have put a file called as dummy. Okay, now let me create one more machine, that is we'll create one more container. Okay, now here let's say docker run -name test00. I'm just using another container, and for this, how is that now I can access this particular content from this container? Okay, now if I want to access the volume which is available in this container, then we will be using an option called --volumes from. Okay, so when you say volumes from and give the name of the container, whatever the volumes that is available in that container, it will be available here also. Okay, so that is what it means. So now here we will say volumes -from and the name of the container ID or the specific name what you have given using the --. Name. Okay, so here we have created the container using this name, correct? So if I want, I can give this here, and now if you are not just trying to access it, but you need the complete control, then along with the volumes from and the name of the container, you will also give another option called as privileged equal to true. Privileged equal to true means now from this new container which we are going to create, we are not only going to access a volume which is available inside this container, but we are also going to write some content into it. So that is what the privileged equal to true will be doing. So once again, the name of the image and the entry command. Okay, so now in this, if you go, we have created a new container and the name of the container is test00. Okay, and now inside this, if you go to user, you can see that even this has a folder called data. But what is this folder? You can see this is the folder which we are trying to access, which is running inside this container. Okay, and anything that you do now, both are been sharing it. So in this, if I create one more file, dummy2, okay, you can see C2 files. Now the same thing if you go inside this container, because now in this screen we are in this container. In this, you can see that it is visible. Same thing, if I remove a file, the same thing here, that will be available. So that is how you first create a container, and for that, while creating, you specify what is the volume directory that you want to create, and then while creating another container, you give the volumes from that particular container. So whatever volumes that is available in this parent container, everything will be available to this container also. Okay, and one more thing, as I said, even though if the container is not running, you can still access it. Okay, so how is that you can do? Suppose if I now come out of this, what will happen? The container is not running, correct? If you say docker ps, you can see this particular container ID is not running, whereas this container is running. But now in this, if I want, I can still create any changes that I want. Okay, the container is still accessible. Okay, so even though a container is not running, you can still access the particular volume. So let's say if I go back to it, so if I want to start and look at this, this is a separate container, this is a separate container. Now if I attach to that container ID, and if you go inside user data, you can see you are still accessing it. So that is how, even when this container was not running, we can still access the volume from the other container. Getting it? So if you want to share a directory, then you create it as a volume, and now you can share. Even though the container is not running, you can still access the specific volume which is being shared from that container. Okay, so this is how you share content from one container to another container as a volume. Now this is between the containers. What if you want to share between your host machine and your container? That means now here I have created a container with the volume, and I'm sharing between these two containers, where this container is different, this container is different. But what if we want to share some content between the host machine and the container? There could be some scenarios during that also, right? Wherein you have created a container, but for some reason you want to put some files inside the container from your host machine. So, or try to access some files within the container from your host. So if you want to do those kind of things, then while creating the container, in the -v option, you will not just say the name of the volume inside the container, but you will say the name or the path of the directory on your host machine that should be shared with the container as a volume. So now when you say like this, here the first path before the colon is the path on your host machine, which will be mapped or which will be shared as data under the container that you're going to create. Okay, so that is how, if you just say -v and the path, it will be creating the volume inside the container. Whereas to that, if you give a path of your host machine, then it will create this directory, whereas it will try to create and sync between this, so that whatever the contents that you have here will also be available in this particular directory, and anything that you do will be accessible from your host machine. Okay, so let's try to run that. So now I'll come out of it. Okay, and let me go to the user doc. What I'll do is, quickly I'll create a folder under my home directory, or I'll create under home user docker. Okay, so I'm just trying to create the same directory, and if I go to this, there is nothing, correct? So now here let us create a file, same thing. Okay, and now let's open one more session. And in this, now okay, so here let's create a new container. So I'll say docker run and -it, and here we will say -v and the path colon, what is the folder that you want to put it as a volume inside the container, so anything that you want to keep, and the name of the image, and followed by that if you want to give a entry point to the command. So we are inside this container, and if you go to the user data folder under this particular container, you can see you are accessing the file from the host machine. Okay, so here let's say host, you can see this is different. So if I want to put this, I'll say echo host. Okay, so you can see that I have created the same thing. Now if I try to access, you can see that it has been shared it. Okay, so that is how you can use the concept called volume, using which if you need, you can share between two containers, or you can share between the host machine and a container, where anything that you do on the changes to the volume will be directly appearing on all the containers or on the host. At the same time, to access a particular container, it is not necessary that, to access a particular volume, it is not necessary that the container should be running. Even if it is not running, you can still access the particular content from the volume. Okay, you can see I did the exit, right? I am no more inside the container, but still I am able to access this file which was available inside the container. So as long as this container is available, I can still use this particular data. Suppose if I delete it, let's say docker rm, and I delete it, I can access it. Okay, so that is how, if you have a particular container, you can try to access the data from it, whether it is running or not. Shared directory permissions. Okay, now that is when you will be having the privilege true. If you do not give a privileged, then you will not be able to modify, but just access it and see the contents. But only if you say the privilege is equal to true, that is the access permissions that you will be having it inside it. Okay, so you cannot have specifically like this user should be working and this user not, but anything that you apply as a directory will also be applied inside your containers volume directory. So that is how each container will be used only by a particular person, so you will not be having many people connecting to it. Whereas the volume concept is while you're creating your container, if you want to get some data from another container or from a particular host machine, then you can use it. No, privilege is required only then you will be able to modify, because if you just say volumes from, you are just trying to see the content, but if you want to put some content into it and access it fully, then you will say privileged. But practically, yes, it is only from a container to a container, not from the host machine to a container. Yeah, because the container, where is that you are creating? You are creating from the host machine. So the host machine has the complete control over your container. So that is how between a host and a container, you do not have to give. But specifically between container to container, you will not know who is creating that container. So in that case, you need a privilege. Getting it on what is a container, sorry, what is a data volume and how do you share it? Okay, now at any point of time, if you have created a container, there will be a unique ID created for the containers. Okay, now you cannot change the unique ID of the container that you have created, but you can change the name that you have given to it. Okay, not the container ID, but you can change the name that you have used for your reference. Suppose if you want to rename a container, then you can say docker rename and what is the name that you want to give. But remember, this is only the name that you have given, not the container ID. So here, if I say quickly docker rename test00 to test01, you can see it has renamed and it has kept the same container ID. So it is just like a reference name that you're giving, which you can always change it. Okay, so do remember, you can change the name but not the container ID. Okay, now so this is all about what is that we do on the container. So we create containers, stop containers, see what is running inside it. Okay, see the events that you have. You want to inspect it, we can also do it. And pretty much if you want to run something inside the container without going inside the container, you can use docker exec, right? And after that, if we want to access an application running inside the container, then we will be using a option called as port, where we will expose the port to the host machine and then access. The same thing, if you want to share some content between two containers or between the host and the container, then you will use the concept of data volume. Now, a container is basically a virtual machine which a user will be creating and using. But when we go as a DevOps engineer, we will be doing much more things beyond it, where now for creating a container, what is that you need? We will pretty much need an image, correct? In that, in the first session I said there are a couple of images which are available by default in the Docker open source community, which we can download and use. So that case, if you want to know what and all are the images that is available in the Docker's community, then you will use a command called as docker images. Okay, so if you say docker images, now what it will do is, on your current machine, that is on your current machine where you have the Docker engine or the Docker daemon running, in that whatever images that we have downloaded and we are using, it will be showing. So in this you can see I have used some 3 images. Okay, so like this, any point of time on your machine or the Docker engine on which you are running, what and all are the images that is available which we have downloaded from the open source community. Okay, so everything will be displayed here. And if you want to search for a set of available Docker images on the open source community, then you will say Docker search. So if you say Docker search and give a string, compared to that, whatever the list of images that is available in the open source community, it will be showing you. Suppose if I simply say Ubuntu, now you can see it will be showing you various images of Ubuntu which is available, in which each image will be having specific additional applications or packages inside it which we can use for a specific purpose. Okay, so now if you actually see, we don't have to create an empty container, because now the major advantage of Docker is Docker gives us an image where we will be having not just a operating system's image, but on top of that, whatever application that we want, we can run inside it and you can download the image directly. So that if you create a container using a particular image which has certain files inside it, as soon as you create an image and from that if you run your container, everything will be available inside your container. So an example that we just saw some time back is Nginx, where if you really see, this is actually an image name where inside that there is some particular operating system which I am not interested, but by using this image we were able to create a container inside which Nginx web server was directly running. So those kind of things can be done using Docker. Now for that, let's say Docker search and Jenkins. Okay, so now what is it going to do? It is going to give you a list of images in which there is some operating system available, and on top of that they have already installed Jenkins and kept it. So that is how you can try to make use what is that specific image that you want. From that, if you create a container, all that specific application, whatever that you have in the image, will be appearing in your container so that you can start using it directly. You don't even have to install anything. Okay, so that's the advantage of using a Docker image, because what we used so far is a simple Ubuntu based image where for our understanding we used it. But pretty much now what we can do is we can try to use a particular image which has certain applications pre-installed in it, so that now if you create a container and from that container whatever the application which was available inside the image, you can directly start using it without installing. So that's the advantage of Docker, where if needed we can create our own image as per what we need. Okay, so that is how. So if you think, how did we get all these images? So by default Docker gives us only the base image of Ubuntu, Red Hat or Fedora, anything specifically. But what someone like us would have done is they would have tried to use a Ubuntu image, for example, and in that they would have installed some application like this, and then from that they would have created an image. So that is what, if we directly try to use this image, we will be getting everything that whatever was available inside this image. So that is how in Docker one thing is all about running containers, but the other thing is how is that you can create an image for yourself, so that if you create an image you can give that image to others. So whenever others create a container using that image, whatever that you have put inside the image, that will be directly available for them inside their container. So that is how we can easily replicate the environment. So let's say now if I create a standard container with the Ubuntu base image, I'll not be having anything. And now as soon as I put some files and applications, from this, if I create an image, and if I give this image to anyone else, and if they create a container out of that, then in all of the containers that they create, they will be having a complete environment replica what we have given inside the image. So that is how we can easily replicate the environment. And not only that, as an example I said, you can install whatever you want inside this container and create an image out of it. So that now if anyone else is creating a container on this image, then we will be having the entire environment or the application inside it. Okay, so there is no limitation on how many images that you can create. It's practically how much you can store on your machine that the Docker engine takes. Okay, as of such, there is no limitation, because now for every product or every process, you can create your own image where you will be setting up something by default and give it to the users. So that is when, as part of DevOps for doing automation, we don't have to create a separate container from scratch and then install everything inside it. You can make use of certain particular container where in the container all you have to do is use an image which will be containing all the applications that you needed pre-installed. So that's how, as soon as you create a container out of these images, you'll be having that application running inside your container. Okay, so now let's try to understand on how is that we create our own image. So basically we don't call it as creating an image, but we call it as building an image. Okay, so to build an image, first we will have to create a container manually, and from that container what we will do, we will try to create an image, and going forward if anyone is using that image, they will be getting all the environment which is available inside it. Okay, so let's try to do that. So first what I'll do is, so you can see if I say Docker images, I have only 3 images available with me. Okay, now what I'll do is, first thing, I'll create a new container. So I'll say this as template. Okay, or I'll call it as image template, and then for this I will use Ubuntu. Okay, now when you are using this base image, as I said, you will not be having much of the things inside your container. It will be like a empty operating system where you need to install all the packages that you need. So first what we will do is, if you say the basic vi command will also be not available. Okay, so if I say which vi, it will not be available. Okay, so let's install a vi package or vim package. Okay, so you can see the vi command or the vim command is not available. So now what we'll do is, first let's try to install it. Okay, so to install in Ubuntu machines, you will use a packaging manager called as apt-get, and for that you will say install and the name of the package. Okay, first we need to update. Okay, I've updated the operating system level files, and now if I install, it is going to install. Okay, now along with it there are certain dependencies, all the packages is getting installed inside our container that we have created. Okay, now because of which if I say vim, you can see that the vim is available. Okay, so now if not, the vim is not going to be available, correct? So I have created a container, and inside that container we have basically installed a simple VIM package. And to cross check, what I'll do is I'll go to the CD temp folder, and there is nothing inside it, right? In this I will use the same VIM, and here I will say test file. Okay, this is a test file. So I have edited the file and I have modified the file inside this container available under the temp folder. Okay, now from this container, how is that we are going to create a new image for us? So to create a new image, you will have to say docker commit and the name of the container or the container ID. Okay, so let me come out of it, and after coming out, you can either use this name or you can use this name. Both are same. So now if I say docker commit and the name or the container ID. Okay, so now you can see that it has created a new image. To cross check, if you say docker images, you can see it has added one more image, but it has given only a image ID, because just like how you have a container ID, for each of the image you will be having an image ID and a name corresponding to it. As of now, we have just created an image, so it will contain only the name of the image ID, but it will not be having an actual name attached to it. So to create a name and attach to it, you will use the command called as docker tag. Okay, so if you say docker tag the image ID and the name of that image. So if I say the name of the image is my image, okay, you can see now the same thing is updated with the name called my image. So now what we have done, we have created our own image called as my image from a container, where this image, now if you look, what did we do? So basically we first created a new container from a image, right? So let's try to put it up clearly. Now first we had a Ubuntu base image. Okay, and from this base image, now we try to create a new container. So when I created a new container, what happened? This Ubuntu's base image, whatever was available inside this, was also available inside it. That is inside the container. Correct? So first we put it up like this. And now because of this, if you go inside the particular container that we have created, we would have been treated as a specific Ubuntu machine. Now from this, what I did, on top of this we try to install a VIM package. So that is what we did. So on top of this, I installed a package called as VIM. Okay, and now, and then we created a file called test file under temp. This is what we did. And from this, what did we do now? We created an image. So when we created our own image, okay, this is my image that we created. Now what and all it is going to contain? Now this image first contains one layer of your Ubuntu, and then on top of that it also contains one layer where you have installed VIM, and then on top of that you have created a file. So it is going to have all the three. So you have first layer Ubuntu, and then you have the VIM package, and then on top of that you created a file under temp. So all the three things were available. Correct? So this is what our image basically contained. And from this, Now if I create one more container, what will happen? So now if I create a container from this image, we will be getting the entire thing as it is inside our container. So that now if I go inside this container which is created based on this image, I'll be having the Ubuntu as an operating system, and top of that I will also get the vim package, and along with it I'll also get all the files that I've created as test file. That is what we are going to get. So now using this image I can simply say docker run -it, and I will give this one. See, now this is the name of the image I'm going to give, and simply bin bash. So if you go inside, we are inside the container which we have created using this particular image. So first thing, if you want to see what is the operating system, it is Ubuntu. Okay, and then in this, if I try to see a file called test file, it is also available, and along with it, if I want to check whether the vim package is available, it is also available. You see, everything is available. So that is how we can create our own image from a container, and using this, if anyone else tries to create their own container out of it, then they will be getting the same environment being replicated. Okay, so that's the advantage, where now we can create our own container where we want to install anything we can install, just like how we saw for Jenkins. Also, one of the example when we were doing continuous integration, if you can recall, we also saw something called as Artifactory, right? So we don't actually have to install anything. We have many default images available, where inside that you have certain applications which is built in on top of it, and from that we have created an image. The same way within the organization, if you want to share some environment, you can always create a container, put some content into it, and create an image, so that anyone who is going to create a new container out of that image we created, they will be having the same environment replicated. So that is how within a no matter of time you can replicate the same container into as many containers as you want using this image. So that's how you can easily replicate. At the same time, the same environment can also be replicated and without any effort, wherein if you want to start, you can start at any time and you can stop it. Okay, so that's the advantage of using a Docker on the other half of creating our own image. Suppose while creating a container, after that, if you want to create an image directly, if you want to assign a name to it, then when you are running docker commit, you directly say docker commit the name of the container ID and the name of the image, and it will be directly creating it. So rather than creating the image ID first and then attaching a name, you can directly do this using docker commit the name of the container from which you want to create a container, and what is the actual name of the image which you want to create. Okay, so that is how we can create our own container. Sorry, we can create our own image. Getting it?